Hi, and it seems like our neighbor dog is not yet done with his or her shenanigans. This is Sir CJ, and this is the 43rd edition of Physics 9. This edition of Physics 9 is actually composed of the following three parts, and as you can see, they're still under gather information, like all of them. The first part is an independent problem solving on thermal efficiency since we remember that in the previous session, ito na yung ginawa ninyo actually. So, in our edition of Physics 9, we're always doing it this way. Bale, you're gonna be given a guided problem solving activity, and then I'm gonna give you an independent problem solving activity. Right? Ganun yung ginagawa natin. I think you're gonna be needing here a one-half crosswise sheet of paper. And then the second one naman is a discussion about the second law of thermodynamics, which we will be exploring through activity number 76 titled Just a Drop. Okay, so I hope that you're ready with this activity. Although I'm gonna be giving you naman enough time to prepare your materials, and if we're gonna be doing this face to face naman. It might be, kumbaga, like I'm gonna announce that we're gonna be doing it, tapos we're gonna schedule it siguro for the next meeting so that you have time to prepare the materials. But if you're doing this as a kumbaga at home, you can actually just pause this video noon and then just look for the materials if they're available at home. And if they are not yet available, maybe skip it muna and then or maybe stop it muna and then make them available and then do the activity and then you can proceed. Okay, so for this session, we still have the following learning competencies. By the end of all of these sessions in book number 23, you should be capable of constructing a model to demonstrate that heat can do work. And then the second learning competency naman is that you should be capable of inferring that heat transfer can be used to do work and that work involves the release of heat. And then the last learning competency naman is for you to be capable of explaining why machines are never 100% efficient. This session, along with all other sessions in Physics 9, are based on the 7A based self learning module in Science 9, which I wrote. Particularly, you will find these parts on the 14th to the 15th pages of the 23rd book of the 4th unit. Alright, let's begin. Medyo excited na rin siguro itong aso dito sa, sa kapitbahay natin. Ayan. So, for the first part, as it was said kanina, you'll be solving this problem independently. So, please get a one-half crosswise sheet of paper and your pen and your calculator and compute for the following. So, consider that a heat engine that received the same amount of thermal energy as the first one kanina, which was 194.5 joules, only produced 100.2 joules of thermal energy to the heat sink. Okay, so how efficient do you think is the heat engine? You may now begin answering this question. Please make sure that your givens are listed properly. They have, a correct set of units, right? Okay, and then make sure that you label your components, the givens, and the solutions. And then follow these steps and then box your final answer and make sure that it is a percentage. Okay? Me now begin. Are you done? Okay, so the correct answer for this is that the heat engine is 48.48% efficient. It's a bit more efficient, isn't it? All right. So this ends the first component of this video lesson. We are now going to proceed to the second one, which is a discussion about the second law of thermodynamics. The first law of thermodynamics is actually saying so much about the input and yung output ng thermal energy in a heat engine. And I hope that with those explanations as well as the discussion about thermal efficiency and yung discussion about how to solve problems about thermal efficiency, gets nyo na yung first law of thermodynamics. Now, in the second law of thermodynamics, medyo actually hindi naman siya about the same kinds of things. It is speaking about something else, okay? Something that is beyond heat engines. It tends to explain what is happening in the entire universe. Okay. So, hindi lang yung about sa Aeoli pile, hindi lang siya about yung about sa mga trend. It is actually talking about or trying to speak about a basic truth that makes the universe work. And it is how disorderly, how chaotic, increasingly chaotic the universe gets as energy transforms from one form to another. What the second law of thermodynamics is saying is that all natural processes lead to the increased disorder in the universe. It leads towards an increasing amount of entropy in the universe. It speaks about how some atoms, some molecules were organized in the beginning, pero what's gonna happen to them after a while is they're gonna be disorderly. Okay, they're gonna be kumbaga magugulo lang sila. They'll always be going to that phase na magkakagulo ang mga molecules, magkakagulo ang mga particles, magkakagulo ang mga atoms. They're gonna be bumping against other atoms to produce more and transform energy from from one form to another, and in that case increase the amount of disorder in the entire universe. And it seems like this disorder is the natural way for things to go. The second law of thermodynamics is something that we can explore in the last component of this video lesson, which is activity number 76, titled Just a Drop. The objective of this activity is for you to be capable of analyzing and constructing models of energy transformation that shows how thermal energy can actually do work. Now remember that everything muna, before you proceed, that everything contains thermal energy. Yun nga lang, ang ibang mga bagay, they contain less thermal energy. Iba namang mga bagay, they contain more thermal energy. The materials you're gonna need for this are the following. So your sheet of paper, pencil or pen, water, a transparent glass that is intended for drinking, and any color of liquid food coloring. Preferably liquid yung gagamitin natin. Now, as soon as you have these materials, let us begin with the procedure. It's actually plain and simple. For the first step, lagyan mo lang ng tubig yung glass, and then make sure na yung tubig is still na siya. Hindi siya yung gumagalaw pa, ganun. Make sure that it's just still inside the glass. For you to facilitate this, the stillness of the water, just put it on top of a table. Wag mo siyang hawak-hawakan. Wag mo siyang hawakan the whole time. Just put it on top of a table or maybe on the floor if in case you want to make sure na hindi siya mag-spill chaotically. Okay? Alright. Now, the second step is for you to add a few drops of food coloring. Drop some at the center. I am urging you to do this very carefully, okay? At wag nyo siyang i-stir ha. Wala naman sa instruction natin na i-stir mo siya. Just drop some liquid food coloring. I actually suggest start muna with 1 drop. Okay? And actually, maybe 1 drop is enough. Okay? Okay, now go ahead and do it. And yeah, I'm thinking that you're seeing some kind of activity right now. May nangyayari dun sa food coloring, right? Okay, now let us try and answer the following guide questions. Pull your no, your answer sheet with you. Kunin mo siya. And let us attempt at answering the following guide questions. The first one is what happened to the food coloring when you dropped it in the water? Anong nangyari? So please try and explain what happened as concisely as you can. Are you done? Let us now proceed to the next one. Question number 2. Did the food coloring mix with all of the water inside the glass immediately? Like, can we say na mabilis yung pagmimix ng coloring with the entire body of water that is trapped inside that glass? You can actually answer this with a yes or no. And then the last question is, now that you know that all processes are actually leading to greater entropy or disorder based on the second law of thermodynamics, how will you explain what just happened in the activity? You may now begin answering this question. Are you done? Okay. Let us now answer. Let us now look at the correct answers, okay, for the guide questions that we had in this activity. For the first question, what happened to the food coloring when you dropped it in the water? What happened was at first, it was only in one corner or in one area of the water, but then it started slowly mixing with the water. Remember that in this activity, you did not stir the water, okay? All right. For the second question, the answer is no. Okay, hindi naman siya kaagad like nagmix ng kaagad and kumbaga all throughout the water. It still took some time. And then the last kumbaga the answer to the last question is knowing that all processes lead to greater entropy or disorder based on the second law of thermodynamics. How will you explain what just happened in the activity? The food coloring was actually in a lower state of disorder when it was first dropped to the glass of water. So nung una, hindi pa siya ganong in a state of disorder. Kumbaga, if there was disorder because of its innate thermal energy, mababa lang. Okay? Now, the particles of food coloring slowly experienced increasing disorder because particles of water were interacting with the particles of the food coloring. So, di man natin to nakikita, pero yung particles ng tubig, nakikipag-interact siya actually dun sa particles ng food color. Kaya anong nangyayari, nagkakagulo sila. Okay, so now that eventually resulted to the mixing with the water as time passes by. Even without stirring, nagmix yung food coloring dun sa tubig. Okay? We're not actually doing anything there. We were not facilitating any movement. Pero, merong mechanical energy yung mga particles ng food color at meron ding mechanical energy yung particles ng tubig. Hindi lang natin sila nakikita, okay, pero meron. Paano natin to napapatunayan? Nag-i-interact yung mga atoms eh. They're moving, di ba? They are covering a certain amount of distance. So, we can say that there was mechanical energy in those particles, and they are always they are moving towards a greater amount of disorder. Kumbaga, mas nagkakagulo sila. Dati, organized sila, sama-sama yung particles ng food color, sama-sama ang particles ng water. But then, the way of nature is always towards an increasing amount of disorder. So, ang nangyari was they mixed up. Okay? They mixed up because of that increasing amount of disorder. All right. That's it. That is it for activity number 76, just a drop. And I hope that with that activity, we were capable of exploring the second law of thermodynamics. Kumbaga, meron tayong proof of an increasing disorder. We can also see that naman, di ba? Halimbawa, yung chemical energy na mayroon ng mga tuyong dahon, pwede silang ma-turn into thermal energy kapag sinunog, right? And then that thermal energy is going to produce halimbawa smoke, which is also hot. It's a hot, kumbaga, bits of gas particles, no? Tapos yung mga bits of gas particles na yun, in the smoke, that's the smoke. They're gonna be mixing up naman with the air, or the wind. It's gonna like be like it's gonna seem like nung una yung smoke hindi man siya gaanong in a state of disorder, pero as it gets into the air, mas nagiging disorderly siya. Alright, so in this video lesson, what we were capable of finishing is the first part. In the first part is an independent problem-solving activity, and I think that you can still hear the dog from our neighbor. It's actually around what time na ngayon? 9:23 p.m. So, siguro may nakikita siyang di natin nakikita. And the second part naman is the second law of thermodynamics. We had a discussion about it. And then we explored it dun sa last part, which is just a drop. Now, in this video lesson, what we explored, it's these learning competencies. So by the end of all of these sessions in the 23rd book, well, we are hoping that you are going to be capable of constructing a model to demonstrate that heat can do work. So that was about the heat engines. This is a previous video lesson. The second one is that you could be capable of inferring that heat transfer can be used to do work, and that work involves the release of heat. And then the last learning competency naman is that you should be capable of explaining why machines are never 100% efficient. This has been Sir CJ, and I hope na meron tayong bagong bagay na natutunan dito sa video lesson na to. I'm hoping also that you are following through with the sequence, no, of these video lessons, because I imagine it will be quite difficult for you to move from one video lesson to another without considering their sequence. Okay, so please make sure that you have had an experience dun sa mga first video lessons, yung bandang 41, 40, o kaya 39, before you proceed in this in the 42nd edition of Physics 9. I hope that you are having a great day.